country with a growing population that is undergoing rapid modernization. The increased volume of solid waste and associated logistical difficulties, the steady growth in the cost of waste management, and the risk to human health are sources of concern in this country. The increasing amount of solid waste generated in Jordan has not been accompanied by adequate sanitation facilities or management programs. The poor financial situation of municipalities constitutes an obstacle to modern solid waste collection, recycling, and successful landfill management. Mixed waste is collected without source separation, in addition to which open dumping and co-disposal of wastewater are practiced. Solid waste mismanagement leads to public health risks, adverse environmental impacts, and other social and economic problems that put increasing pressure on the infrastructure as well as the authorities responsible. The objectives of this research were to investigate and evaluate the existing solid waste management system as well as the current policy, institutional, legal, and financial framework for solid waste management. To review regulations, compare options, and identify the needs of this sector. To determine the problems associated with current practices, especially landfilling and source separation, with focus on the environmental impact of solid waste landfills, and describe the main obstacles to developing this sector to a sustainable level in the future, and to suggest design parameters and operational methods for sustainable landfill operations in the light of the current financial, social, and environmental situation in Jordan. Field and lab experiments, numerical simulations, as well as surveys were used to achieve these objectives. The field experiments were conducted to gather information about the sanitary status of Mafraq landfill by investigating the leachate and groundwater quality in its surroundings. Lab experiments on typical Jordanian waste were undertaken to explore the effects of landfill practices and climate on emission potential from landfills in Jordan and similar regions. Modeling and numerical simulation were used to compare different waste management options and their effects on climate change and greenhouse gas productions. The daily landfill cover of Mafraq landfill was studied, while in Akadir landfill, a water balance equation was applied to predict the leachate generated by the co-disposal of wastewater and its possible effect on groundwater. Two surveys were conducted. The first was designed to explore the public perception and awareness, as well as willingness to recycle municipal solid waste and to determine best solid waste management practices. The aim of the second was to describe the role of scavengers in waste management in terms of waste reduction and material recovery. Field experiments clearly demonstrated that Mafraq landfill doesn't meet the standards of a sanitary landfill, as the leachate is free to interact with the groundwater aquifer. Furthermore, the leachate analysis revealed that the soil under the landfill is contaminated. Groundwater in the vicinity is unsuitable for household use due to high concentrations of fluoride and mercury, which, if ingested, can cause serious health problems in humans. Lab results provided evidence of the production of a significant quantity of leachate and landfill gas during wet seasons. However, the gas and leachate production rate was negligible in summer. Significant traces of heavy metals were found in the leachate due to mixed waste disposal, indicating that the landfill design and operation could be improved. Modeling of various waste management options revealed a vast reduction in greenhouse gas emissions when organic waste was separated and either composted or treated in anaerobic bioreactors. The numerical simulation of landfill daily cover demonstrated that clay loam was suitable for Mafraq landfill cover as well as for sites with similar soil and climatic conditions, as it had the lowest penetration depth at the end of the simulation period. The simulation result for the suggested water balance equation illustrated that the co-disposed wastewater plays a major role in controlling the rate and magnitude of contaminants percolating from municipal solid waste leachate and increases groundwater contamination. Finally, the survey revealed that the people in Jordan had a very low level of knowledge about recycling, albeit a positive attitude towards and willingness to learn more about it. Indeed, satisfaction with municipal waste collection services was very high. Thus, source separation at the point of generation will be difficult to achieve in the immediate future in Jordan. It was found that the scavengers play an important role in informal solid waste management, especially in terms of waste reduction and material recovery. The value of the scavenged material makes scavenging a relatively profitable business for poor people and could attract more in the future.
My name is Hans Hansson and I'm professor and head of Department of Water Resources Engineering at Lund University in Sweden. I've been very happy to have Mr. Aljaradin here for 4 years, and the work that he presented today was actually a very big step forward in his field. So we are very happy about his work, and I'm sure he can make a good contribution to his country when he returns, because solid waste management is an important issue in Jordan as well as in Sweden. So this is a very important progress that we have seen presented here today. And in fact, Mr. Aljaradin, he was been one of the most sort of foremost PhD students that we've had here over the last few years. So we're going to miss him not only as a researcher but actually as a person as well. So it will be a sad moment for us when he returns to Jordan, but the luck is yours. I'm sure you will get a very successful employer in your system in Jordan. Thank you.
My name is Kenneth Persson, and I work as professor at the Lund University in Lund, Sweden. And I have been supervising the work that Mr. Mohammad Aljaradin has presented today in the thesis towards sustainable solid waste management in Jordan. Dr. Mohammad Aljaradin, he presented his thesis towards sustainable solid waste management in Jordan today at Lund University in Lund, Sweden. In the thesis he has written about different aspects of solid waste management, and particularly how the solid waste management system operates in Jordan. And looking into all the results that he has presented, it's interesting, I would like to say, to highlight that first of all, that there is a lack of clear environmental solid waste law for Jordan, and that means that the policymakers needs to address and develop a modern solid waste management law for Jordan in order to how to declare how the country should be organized when it comes to solid waste management. Secondly, he shows that the current waste management situation requires lots of improvements, which however can be implemented. For instance, he indicates that there is a strong potential to increase the recycling and to increase the composting and digestion of organic waste that contributes to more than 50% of the total solid waste flow in Jordan. And thirdly, he shows a very interesting economical opportunity, because if waste is handled properly, there will be good reduction of greenhouse gases, and these greenhouse gases, they can be used in the greenhouse gas trade, cap and trade system. So there can be economical benefits for the country of Jordan if that is addressed properly. So there are many interesting opportunities to go towards a sustainable sustainable solid waste management situation in Jordan, as he outlines in his thesis.